Hello everyone, let's look at today's Leetcode problem 1857, largest color value in a directed graph. Before starting this problem, let us look at a motivational quote for today. Strive for progress, not perfection. Every day you learn, you are getting better even if it doesn't feel like it yet. So this quote kind of gives us uh, an information that we should never uh, compare uh, compare to anybody that has a huge success than us. So we should always strive to get better each and every single day, and we should never uh, compare ourselves to anybody else. Even if we are making a small set of progress when compared to our previous day, it is a progress, and we might need to stay happy with whatever we have progressed, and we might need to keep going forward. Let's understand the problem statement. There is a directed graph of n colored nodes and m edges. The nodes are numbered 0 to n minus 1. You are given a string colors where colors I is a lowercase English letter representing the color of ith node in the graph. You are also given 2D array edges where edge j, aj, bj indicates that there is a directed edge from the node aj to the node bj. A valid path in the graph is a sequence of nodes such which connects x1 to x2 to x3 and so on, such that there is directed edge from xi to xi plus 1 for every I less than k. The color value of the path in the number of nodes that are colored, the most frequent occurring color along the path. Return the largest color value of any valid path in the given graph, or -1 if the graph contains a cycle. So we know what a cycle means in a graph. So uh, if the starting node and the word cycle, we if in directed graph, uh, ending node connected to each other, then it's cyclic graph. Okay, so let's look at this example where we have given with colors A, B, A, C, A. So this represents each character in the string represents the color of a specific node in order. So 1, 2, 3, 4, 5. So this indicates that there are 5 nodes. So the number of characters in the and this gives us an information on the edges that are connected with respect to the nodes. 0 is connected to 1 and 0 is connected to 2, 3, 4 and so on. So this is a valid path and this is also a valid path. But if we look at the problem statement again, so we might have to return color value of a path is the number of nodes that are colored the most frequently occurring along the path. So if we see there are red, red, blue. So in this path, we see red is equals to 3 and blue is equals to 1. So, and here if we see blue is equals to 1. So our answer should be along this path which has a value of red 3, and that's the output that we see here, right? So similarly, since we see the starting node and the ending node to be the same, this is a cyclic graph, and we can simply return -2. This is shown in example 2, right? So yeah, number of nodes is equals to color length, and m is equals to the edge length. Okay, so it would be of 10 power 5. Colors consist of lowercase English letters. Okay, so let us look at this example. So let's try solving this example through an approach, maybe a DFS approach, where let's say and let's mark, let us only calculate for the longest path where there are as many nodes as possible, and we see this path contains only this path contains only uh, this path contains only two nodes. So if we are taking this path which has more nodes, then we can have our answer. So this would be another crucial point. So let's say we do not consider this node and we strike it off, as our longest path would be these are the four paths. So 0 to 2 and 2 to 3 and 3 to 4. These are the three different edges connecting these four nodes, right? So if we need to, let's say we mark this red, blue. Let's say we calculate a color. Let's say we start off with the end node, and we say this has a value 4, and we have not seen any uh, so yeah. So let's say this has a value 4. Fourth node has a value uh, let me take a neutral color, maybe. Yeah, so fourth node, the node 4 has a color of red, and we mark this with 1, while we do not see any nodes, or we do not see any possible nodes at 4. But we once we check the previous node, maybe in a breadth first, breadth first traversal, BFS traversal, we calculated this direction where we take the first node, and then we consider this node and the next set of nodes as we follow. So this would be 0 and this would be 1, and in the second node we okay, so I don't know why I keep marking red as Okay, so zeroth node would be the starting node, and we would be having red as the value 1 here. And once we look at the second node, which is this one, might we have already seen 1 here, so it would be 1 plus 1, that is the previous occurrence of 1, and this would be 2. And still we have not seen any uh, nodes which has a color blue. And once we reach 3, we know that the previous value 2 stays there, and we see a node 3 which is colored with blue, so we mark it with uh, the value 1 and 0, since we have not seen any previous occurrences. And once we go to the next node, where we have visited two nodes which have the color red, and in the node 4 has the color red as well, so we increase its count, and this would end up with 3, and here we would end up with 4. So yeah, so and in this longest path we see the value 3, which is associated with the color red, has the highest color frequency among any path. This so we might have to consider all the possible paths and check for the highest value of a specific color. So we know that there would be the colors range would be of 0 to A to Z, which means we can only have a color combination of 26. And that's something that is stated here implicitly, if we understand this problem statement better, because n, which stands for number of nodes is with colors length, and colors length will be of colors consist of lowercase English letters, which would be mostly with 0 to 26. This is the crucial part to consider in this problem statement, right? So yeah, uh, so we might, if we will have to approach this problem, there are let me write down few things that we would be looking to solve here. So yeah, so okay, so first thing is we construct a graph with the edges that are given. So and once we construct the graph, we we create a queue uh, to perform where we would be using BFS. So we push all of the items to the queue with respect to each path. So and we also create a count array, which would be of array size n rows corresponding to the number of nodes, and each node will be filled with 0 to 26 corresponding to column. So as we saw in this example where each node would have certain color value, so we are going to assign each row with a set of color values. So this would be like A to C. Yeah. So once we do that, we visit all of the elements in the queue, and we dequeue after each operation, and we do that with a while loop. So we take each of the node and we check what is the, so as we did here, we performed a check on each individual node on what color count it had, and we also used to append it to the next set of color values. So let's say this had red of 1 and blue of 0. So here we add the next value with blue of 0, right? So we continuously uh, let the neighbor know that the previous set of values were these, and we also consider the current node color, we added it to the with the previous node, right? So that's one operation that we do here. So we update neighbor node, and once we do that, we check for, we keep track of a max count. We and we at the end, we before returning the result, check if cyclic. So this can be checked if all the nodes are visited, else we return, else we can simply return the max count of color. Okay, let's try solving this in our Leetcode editor. So this would be number of nodes, and we start building our graph. So for every node with starting and ending value, we push it to the graph so that it's a valid path. And let's also have a in degree graph where this helps uh, in degree graph, this helps uh, see all the possible nodes that are coming to a specific point of node, and this also helps us in further calculations of if a node is cyclic or it is going back to the starting point of the node. And yeah, so we every for each edge we mark the graph uh, path, and also in degree path, just to denote the number of incoming nodes at a specific node that we are looking for. And now we add items to the queue. And also create a new array for storing the count of colors for each character A to Z. So we push the node which is like the starting node, where it doesn't have any incoming nodes, and we can say that 0 is an starting node where there is no incoming node but there are set of outgoing nodes. Yeah, so this can be done with in degree array, where we keep track of n nodes which will have set of incoming nodes or the incoming nodes with this piece of statement that we have written here. And we push the starting node, and we perform BFS to find the max count of the color frequency. And we also set a visited variable which gets changed to 1 or so if there are cyclic uh, for every visited item of a node. And we are going to run this while loop as long as there is item in the queue, and we are going to get the first item in the queue and mark it as visited. So we are going to check at the end if all of the visited nodes um, would be equal to n number of nodes, and then if the value doesn't match, then we can assume that it's a cyclic graph, right? So that was our thought. So let's see which color the specific node is with, and we do that with this operation where we take the color code of the node value and we subtract it with 97 to get the specific letter or the color index. So from this we increase the count and we use the color index as reference, and we increase the count value. We update the max count variable with once we do that, we also trickle down the next neighboring nodes uh, with the previous value of the graph. We do that this way. We update for all the color codes. And we also subtract the in degree nodes which are incoming for a specific neighboring node to -1 as we have updated it. And at the end, we push the specific node once there are no incoming nodes with it. So we check if the neighboring node doesn't have uh, any more incoming nodes, then we consider if there are any branches from the specific node. Let's say 3 would have certain other branches to it. So we do that and we push the specific neighboring node here to the queue for further exploration. And after all this, we return the value. If all of the visited items is else minus 1, right? So yeah, uh, I hope we understood this part where we are checking all of the neighboring nodes with a specific graph, and we are also having to push, we are updating the count value, and we are pushing the neighboring node if there are any no if there are no incoming nodes to it, and we are pushing it to the queue for further exploration. And yeah, so let's try submitting the solution. The time complexity of this type of solution would be, if we would be exploring at the max all of the, okay, so in degree. So time complexity of this type of solution would be uh, n plus m, where we, okay, as we are building the graph firstly here with all of the edges which might be of length m edges, and initializing a count which is of 26, that's one thing, and we are also having to iterate on each of the node at the max of n times, so on all of the nodes. So that would be the whole point. So let me see what's the error here. So in colors dot length, okay. Okay, now it should be submitting. So yeah, let's see. As you can see, the solution gets submitted. If you found this video helpful, please like and subscribe to my channel. Thank you.